Okay, this is differential equations, part two. I'm just going to do, I don't know, 4 or 5 problems that are just maybe slightly more complicated than the other ones, but I'll just remind you that all of these, meaning everything in Calc AB and Calc BC, and even most college Calculus 2 classes, they're all separable differential equations. So let's do the first one. Y prime minus 4yx equals 100x. Okay, so let's start out with something like that. And again, it's a separable differential equation. So we got to think about how are we going to separate all the y's and all the x's. So I think that the first step is we're just going to add this to the other side and get y prime equals 4xy plus 100x. Then let's go ahead and rewrite dy dx instead of y prime. And on this side, let's go ahead and factor out an x. And what you're going to notice here is that now I can easily separate dy with y and dx with my x's. Again, I factored and I rewrote y prime as dy dx. And now I'm going to divide by y plus 25. So dy over y plus 25 equals 4x dx. Okay, I've separated the variables using algebra. Now I'm going to integrate. The integral over here is the natural log of y plus 25. And over here I get 2x squared plus c. All right, let's pick some initial value. How about when x is 0, y is 10? So let's say we knew this initial value. And again, most of the time, these are all going to be initial value problems. Okay, so let's plug in y of 10. So this is the natural log of 35 equals 0 plus c. Cool, I know c now. Now I know that c is the natural log of 35. So I'm going to rewrite this line. The natural log y plus 25 equals 2x squared plus the natural log of 35. Now remember, if these two things are equal, then as the power to an exponential, meaning I'm going to exponentiate. It's my favorite, one of my, at least, well, it's a top 5 verb, exponentiate. Feels like I'm casting a spell on somebody. A little Harry Potter reference. And e to the natural log then is just going to be this, y plus 25 equals, and e to this, just remember, e to the a plus b is the same thing as e to the a times e to the b. So then e to the 2x squared plus the natural log of 35 is e to the 2x squared times e to the natural log of 35. But e to the natural log of 35 is just 35. So I get 35e to the 2x squared. Review your logarithm rules and exponent rules if I kind of lost you there. And then I can drop this because we know that when x equals 0, y equals to 10, they're all dealing with positive things. And so I just solve for y. So I get negative 25 plus 35e to the 2x squared. This is the solution to that differential equation. Okay. All right. We'll just do some varieties here. How about dy dx equals, how about 6x squared minus x squared y? You look at that and you're like, what? That sounds probably pretty easy. Let's just take away an x squared, or excuse me, not take away, factor an x squared. So dy dx equals x squared times 6 minus y. All right, now I can separate. I get dy over 6 minus y equals x squared dx. Cool. So the question is, this is so easy. Why did I put this on the other one? Like, oh, that negative sign. That negative sign is going to trip people up, guaranteed. Remember, in u substitution, if u is 6 minus y, then du is going to be negative dy, and I don't have a negative. So when you integrate this, you better get negative natural log of 6 minus y equals x cubed over 3 plus c. Okay, be careful. And I don't know, let's say that we know that when x equals 0, y equals, 4. How about that? So this is negative natural log of 2 equals 0 plus c. So now I know c, negative natural log 6 minus y equals x cubed over 3, and then c was what? minus natural log of 2. I'm going to go ahead and move the negative sign first. It's going to be negative x cubed over 3 plus the natural log of 2. Now I'm going to exponentiate both sides. So if those, the blue are equal, then e to the blue are still the same thing. E to the natural log is this. This is going to be e to this plus this is e to this times e to that, but then I just get a 2 out front. Okay, and then I can drop the absolute values because I'm only looking for the positive version. That's okay. And then I'm going to add y and subtract this. So I'm going to get, moving that over, I'm going to get 6 minus 2e to the negative x cubed over 3. And you can just guarantee to yourself that the initial value still is true. When you plug in 0, you better get 4. Plugging in 0 makes this e to the 0, which makes this 1, which makes this 2. 6 minus 2 is 4. Cool. Okay, so we solved that. And again, right there, boom, that negative sign is going to trip people up. Negative sign comes from the fact that the chain rule exists for u substitution or whatever you do for integrals. But you integrate that and get a logarithm, but it's a negative. Okay, so we have that guy. So those are 2. What else could we do? How about, am I even on the screen? Okay. How about e to the x minus y prime equals 4. Okay, so let's move this and move the 4. E to the x minus 4 equals y. And then I'm going to rewrite y prime as this. Okay, now let's just multiply by dx. This doesn't seem too bad. And I get them separated. Awesome. Okay, now I can integrate. And the integral of e to the x is e to the x. The integral of 4 is just 4x. Slap in a whole plus c. The integral of y is y squared over 2. Do I need a plus c? Now again, if we haven't had that argument before, you don't, because a plus c and another plus c, subtracting, you would just get the difference of two constants, which is a constant. So we just really need one of those. And let's say when x is 0, I don't know, what do you want y to be? Y to be like 3? No, let's make it an even number so it divides easily. How about 4? Okay, so this is e to 0 minus 4 times 0 plus c equals 4 squared over 2. And I'm just plugging in my initial value x and y to be able to find the c. So this is 1 plus c equals 16 over 2 is 8. So I know now c is 7. So I can come back up to this line and say e to the x minus 4x plus 7 equals y squared over 2. Multiply everything by 2. 2e to the x minus 8x plus 14 equals y squared. And then go ahead and boom. And what you learned is that you always get this plus or minus, right? But with this initial value, I know which one I need. Because when I plug in 0 for x, I have to get positive 4. So I do not need this plus or minus. I just need the plus version. And I'll put a plus there to remind you of that. Again, I've solved. Okay? And the last thing I want to do, I don't even want to necessarily even solve a differential equation, but I just want to compare and just remind you. And it would kind of depend on the order in which you watch these videos. But dy dx equaling 10y, dy dx equaling 10 times 50 minus y, and dy dx equals 10y times 50 minus y. I want you to recognize and be able to compare and contrast these things. Okay, this, the rate of change of the population is proportional to the population. This is exponential growth and decay. This, the rate of change of the population, is proportional to the population and the difference between the population and the carrying capacity. Remember, this is some k, this is some carrying capacity, m. This is logistic. And maybe you haven't watched the logistic growth, but this is logistic growth. You'll see that. And this is exponential growth or decay. And logistic growth can decay as well. This is different. This doesn't have a special name. It's just a normal separable differential equation. It will involve exponentials. It will look very similar to, well, you know what? I can just go ahead and do this one. We'll do this one down here, but this is your PERT formula, right? This is going to be y equals y naught e to the 10t. That one, that's that. If you separate, that's what that one's going to turn into. And this one's going to turn into y equals 50 over 1 plus a e to the negative, well, it would be km. That'd be a ridiculous term up there. And then you'd have to use the initial value to find a, just like you'd have to use the initial value to find y naught. Again, there's two separate videos, both on exponential growth and logistic growth. There's actually two videos on logistic growth. This looks similar, but it's not. It's not just proportional to the population, and it's not this. It's somewhere in between where it's still related to the population in some difference. So if you did this guy, you would move this on the other side. So dy over 50 minus y equals 10 dx. You'd integrate both sides and get negative natural log of 50 minus y equals 10x plus c. And let's say 0 equals 10 or something. That's the initial population. So then this would be negative natural log of 40 would equal c. Might run out of space here. So then we know that this is negative natural log of 40. I'm going to get rid of this negative sign, so make that positive, it would make that negative, and it would make that positive. Then I would exponentiate, and then I would get 50 minus y equals 40 e to the negative 10x. And then I would solve for y and get y equals 50 minus 40 e to the negative 10x. Okay? And that's what this would look like. So it's not an exponential, it's not logistic, it's some different curve. It just doesn't have its special name. And again, I can't compare and contrast those because they look kind of similar, and I wouldn't want you to jump to any conclusions about what they are. Exponentials are that form, logistic growth is this form, and this type of curve is right there.